All right, so this is discussion 4 in the packet, page 27, about how to use stoichiometry when you're given the mass instead of the moles. Okay, so let's see what we got. How about green? Sure. Okay, all right, so if 94.2 grams of potassium oxide react with excess magnesium nitride, what mass of magnesium oxide will be produced? Okay. All right, so we have our equation to start with. So I'm going to go ahead and balance it first. So I have 3 mg's, 2 n's, 2 k's, and an O. And then over here I have 1 mg, 1 n, 3 k's, and an O. Okay. All right, so I see that the potassiums are 2 and 3, so I think I'm going to start with that because that's going to have to turn into a 6. Okay, so I'm going to try a 2 here, which makes that a 6 and that a 2. And then I'm going to try, where is that? A 3 here, which is going to make that a 6, and is going to make that a 3. Okay. All right, so now I see my magnesiums are out of balance, so I'll try to put a 3 here. That'll turn that to a 3. That'll turn the oxygens to a 3, and now I'm balanced. Okay, so I've got 1, 3, 3, 2. All right, so down here in ratios, I wonder if I can move this up a little bit, see if this works. No, it doesn't work. Hold on a minute. How do I go back? Okay. Oh, there we go. I can't see it all. Darn it. Okay. All right. Okay. So for ratios down here, I'm going to say for every 1 mole of Mg3N2, I'm going to react with 3 moles of K2O, okay, to produce 3 moles of MgO and 2 moles of K3N. Okay. So that's my ratios from the coefficients. All right. So now you're going to actually need to use the molar mass, where we haven't yet, but now you will, okay? So I'm going to trust that you know how to find this, 3 magnesiums and 2 nitrogens, okay? I'm just going to write in the answers here, and I'm going to trust that you know how to find that, okay? If not, I don't know, you got to get some help, okay? This is 94.2 grams per mole. This one is 40.3 grams per mole, and this one is 131.3 grams per mole, okay? All right, now here's the new step. Convert mass to moles if needed, okay? Because in order to do the BCA table, we have to have moles, okay? And we don't know yet what we have. We only know we have 94.2 grams of potassium oxide, okay? So I'm going to go to the potassium oxide column, and I'm going to start with what's given, 94.2 grams. That is what is given, okay? I need to know how many moles that is. Okay, well, this one's really super easy because it's just going to be 1 mole. Okay, so I'm going to do my ratio where I have grams and grams that cancel, and then 94.2 over 94.2, it's going to turn out that I'm starting with 1 mole of potassium oxide. Okay, right? It's not always going to be that clean. Okay, this one's just a little bit easy. Okay, all right, so my magnesium, I have 2 magnesiums. 3 magnesiums and 2 nitrogens in 1 compound. I have 3 KO2s, K2Os. Drawing it right, said it wrong. Okay. I have 3 MgOs. Okay, and then I have 2 K3Ns. 1, 2, 3, and I have 2 of these. Okay? All right, good so far? Okay, let's see if I can scroll this down without messing it up. Okay, let's try here. Okay, all right. So now I have to go to my BCA table. Now it's just like it was before. The secret thing that I had to figure out first was how many moles it is. Okay? So like in an old problem, it would have just said if 1 mole reacts, but now it's going to say it in grams, okay? So I know I'm going to start with 1 mole, all right, of the K2O, and I'm going to use it all up and be left with nothing because that's what's happening in the reaction, okay? It says it reacts with excess magnesium nitrate. That means there's plenty, okay? So if it says that, you're allowed to just write excess, right? And then you're going to use some amount, 1 mole K2O, and then you'll do your ratio, and then you're going to be left with excess. That just means there was plenty, right? It didn't all get used up. There was some kind of leftover, okay? You can also find these values if you want. Sometimes I'll do that too. That would be the amount that's actually required. But if it says excess, that means that there's plenty, okay? So just for practice sake, let's go through here. If I have 1 mole of K2O, my ratio is 3 moles K2O to 1 magnesium nitride, okay? And that's just going to be 1/3 of a mole is what I use, but it doesn't matter because I have what we say is excess anyway, okay? All right, so in my BCA table, remember, this is the important part. So this guy's going to get a mole of K2O, and then I need to do the ratio. Okay, so in the ratios up top here, right, I have 3 moles of K2O go with 3 moles of MgO. Okay, I started with nothing. 1 over, or times 3 over 3 means I'm going to get 1 mole of magnesium oxide. Okay, I started with nothing. Same thing here, 1 mole K2O and 2 moles of K3N. Okay, so that's going to leave me with 0.67 moles K3N. Okay? All right, so now we got to look and see what they're asking for. Oops, I'm going to run out of space there. Maybe I can just do it down there. Okay? All right, now convert mass to moles if needed, because it asks for what mass of magnesium oxide will be produced, okay? But I don't know that. I only know that I'm getting a mole of magnesium oxide. All right, so that's what I'm going to start with, 1 mole of magnesium oxide. Then I have to use my molar mass, okay? The mole has to be at the bottom, so it cancels, and I know there's 40.3 grams of magnesium oxide per mole. Okay, so I'm going to just be left with 40.3 grams of magnesium oxide. So that's my answer. Okay? All right. So let's see if we did it just purely with dimensional analysis, okay, in one big step, how it would look. Okay, so we start with what was given, which was 94.2 grams of potassium oxide. Okay? Then I know there were 94.2 grams of potassium oxide and 1 mole of it. Okay, so now these cancel. Okay, then I have to use my ratio from the equation. So I know that 3 moles of K2O produced 3 moles of MgO. That's what I got from the coefficients of the equation. So that cancels. Okay, and lastly, they didn't ask for moles of magnesium oxide, they asked for mass. So I have to use the molar mass of magnesium oxide, 40.3 grams MgO to 1 mole MgO. That cancels out. Okay, so 94.2 divided by 94.2 times 3 divided by 3 times 40.3 is just going to be 40.3 grams magnesium oxide. Okay, right, which obviously should match. It's the same thing. Okay, this is just how you do it in one big giant step. Okay, but I don't think it's as understandable when you don't look at the whole equation. All right? Okay, so that was number 1. I'll do one more.